Welcome to this session. Today we are going to go through the UCE Mathematics 2025, the ones that Senior 4th did. But now this video is very good for Senior 3, Senior 2, and Senior 1. For Senior 4 students, do not bother to watch this video. But for the case of Senior 1 up to Senior 3, it is a very nice video. And we are now going to look at section A. And in section A, we have two items, item 1 and item 2. Item 1 is under numbers, and then item 2, patterns and algebra. The two items are explained step by step. So find where to write and note down what you may not have understood in the normal lessons. So here the item reads that a parish agriculture officer has received 450 kilograms of fertilizers for maize and 120 liters of anti-tick vaccine for cattle. He intends to distribute the fertilizers equally among farmers and also distribute anti-tick vaccine equally among the same farmers. He wants to establish the number of farmers that will get the items. Joseph is one of the farmers and his daily milk production is 180 liters. He sells 60% of the milk at each shillings 850 per liter, and donates one out of 15 of the remaining milk to an orphanage. He has been advised to use the quantity of milk left after selling and donation to make yogurt and butter in the ratio of 1 to 3. However, Joseph has a challenge of determining amount of milk he should use to make butter. Ask the parish agriculture officer establish the number of Roman 1 farmers that will receive items, kilograms of fertilizers and liters of vaccine each farmer will get, and then also help Joseph to determine the amount of money he collects from milk he sells, and then amount of milk he should use to make butter. Now let us start with part A. Now this first paragraph, now here is all about distribution. When you see distribution in mathematics, then you just know that you'll now use UCF. So we shall now apply the concept of greatest common factor to distribute what we have. So now for the case of this one, equally, as long as you are distributing, you identify that number that can divide two or more three numbers at the same time. But as we are looking at a number, there might be very many numbers, but now we shall go for the greatest common factor. And here we shall come and we say GCF of 450 and 120. So here we will come, and then here we have 450, excuse me, here we shall have, allow me have here 450 and then here 120. So when I divide here by 3, here I get 150 and then here 40. Then when I divide here by 5, here we get 30 and then here we get 8. And then here I can divide by 2 now. When I divide by 2, here we can get 15 and then here I get 4. So here GCF is equal to 3 times 5 times 2, and I get the answer as what? As 30. It means that when the highest number of farmers that can share these the quantities of 2 items will be 30 farmers. So you'll come and you say 30 farmers will receive the items. Will receive the items. Receive the items. So this is item 1. Item 1 part A, then Roman 1. Then Roman 2 says, how many kilograms of fertilizers and liters of vaccine each farmer will get? Especially look at this. When we divide, it means that when 30 farmers when 30 farmers share 450 kilograms of fertilizers, everyone will get 15. And when 30 farmers share 120 liters of anti-tick vaccine, everyone will get 4. So you'll come here and you say that each farmer will get 15 kilograms of fertilizers and 4 liters of anti-tick vaccine. Anti-tick vaccine. Or similarly, maybe you can understand it like this. If we have 450 kilograms, and there are 30, now we are kilograms of fertilizers. And then here we shall have 120, then I divide by again 30. Here we shall have 4 liters, and then here we shall have 15 kilograms. That's why each farmer will get 15 kilograms of fertilizers and 4 liters of anti-tick vaccine. So this is item. That is our first part. For Roman 1 at the same time Roman 2. So that here item 1 was somehow cheap. So we can now look at the part. We can now look at the second paragraph. So the second paragraph here I'm seeing 60%. Now I'm seeing percentage, but at the same time writing numbers in figures. Then I'm seeing fractions, and then lastly I'm seeing ratios. So here they are saying, part B, Roman 1, help Joseph to determine the amount of money he collects from the milk he sells. And here from the question they are saying he sells 60% of the milk at 850 shillings each liter. So here we shall come and we say milk sold. Milk sold. That is 60% of 180 liters. So here we shall have 60 out of 100, then times 180 liters, and so here we shall have the answer as 1080 liters. Then again here you come and now amount got from 108 liters. 1 liter is equal to 850 shillings. Then what about 1080 liters? So here we shall come and we say here it is 108 times 850, and then here we shall have the answer as 918, then a 00. So after finishing that, you come and give a conclusion. So we shall come and we say Joseph Joseph will Joseph collects 91,800 shillings from the milk from the milk he sells. From the milk he sells. Milk he sells. So this is for this part. This is part B, then Roman 1. And now here, they're asking, you come here and say, how much and the quantity of milk he should use to make butter. But here, I'm seeing after selling 60%, remaining milk after selling. Remaining milk after selling. Here we shall have 180 liters minus what he sold. But what he sold was 108 liters. And the answer is 72 liters. But now here, donated. After that, he donated 1 out of 15 of 72 liters. Now, friends, total fraction is 1. If he donated, maybe, allow me take off this. Let me take off this. Now let me take off this. Now here, you can first find 15% of 1 out of 15, then this one. Here you can come and say it's 1 out of 15, then times 72 liters. And the answer here that we'll get will be 4.80 liters. 4.80 liters donated. Then remaining milk after donation. Here we shall come and we say we have 72 liters. Then minus after donation and sale and selling. We shall have 72 minus maybe minus 4.8 liters. So the remaining milk now is remaining milk is 16. The remaining milk is 67.2 liters. But even if you didn't take this direction, just come and ask yourself, if donated was 1 out of 15, then it means that what remained, then here remained is 14 out of 15. So fraction is 1. If 1 part out of 15 was donated, it means that 14 parts out of 15 remained. Still, you can come here and you say that is 14 remaining milk. Remaining milk after selling and donation. Still you can come and say 14 out of 15, then times 72 liters. Still we shall get 67.2 liters. Then also we can proceed. But here, this now milk is the one available to make butter and at the same time yogurt. But yogurt and butter were to be made in the ratio of 1 to 3. Now you need to come here and you ask yourself, what is the total ratio? Total ratio is equal to 1 plus 3. The answer is equal to 4. And now you come and ask yourself, maybe allow me create a space here. Or let me take off this. I take off this one. So here we shall come and we get, so here the total ratio is equal to 4. Then come, how many parts is butter going to take? 3. So come and say 3 out of total parts times the amount of milk available to make butter and yogurt, that is 67.2 liters. And here the answer is 50.4 liters. So here we shall come and we'll give a conclusion and we say that he should use he should use 50.4 liters of milk to make butter. So whichever way you interpret things in mathematics, still you get the same answers. So whoever took that direction of first finding 1 out of 15 is right. And also whoever also understood it this way, that if I donated 1 out of donated, then remained with 14 out of 15. Still both approaches work. But do not forget to give a conclusion always. So we say that you should use 50.4 liters to make butter. So here we have another item that reads, Daria has a cattle section and goods section on her farm. She employed a farm manager. According to the manager's records, each worker in the cattle section takes care of 50 heads of cattle, and each worker in the goat section takes 30 goats. The farmer has a total of 310 animals in both sections. Each worker in the cattle section is paid 150,000 per month, and in each worker in the goat section is paid 100,000 per month. A total of 950,000 is spent on paying workers every month. Daria needs Jaria needs help to determine the number of workers in each section of the farm using the manager's records. And the records also show that for the past 3 months, the manager has been selling milk to customers at a constant wholesale price indicated in the table. Here we have the second row represents the quantity of milk in liters, and then the third row represents the amount of money got from sales. The first month, 100 liters of milk were sold, and 150,000 shillings was collected from sales. Then in the second month, he sold 80 liters and got 120,000 shillings. And then the third month, then the liters sold of milk rose to 120, and then 180,000 was collected from the milk. So here the manager has informed her that the farm is likely to produce 135 liters for sale at wholesale price next month. And Jaria needs assistance to use the sales records to form an equation that she would use to determine the amount of money to be paid by any customer who buys any quantity of milk at wholesale price. Determine the number of workers task. Help Jaria to determine the number of workers in each section of the farm. Then part B, Roman 1, form an equation that she would use basing on the records and state the constant wholesale price each liter of milk. And then lastly, part 2 of part B, calculate the amount of money she's likely to receive from the sale of milk next month. Now, when you read this item, the first paragraph here, as you can see, the first part is all about simultaneous equations. As you can see, two totals there and also two conditions, but talking about the same things. They are talking about here workers, and then another part they are asking number of workers. For such number here, this item 2 needed simultaneous equations. And now here under patterns and algebra, the first part that you should think of, or what you should keep in your mind, is defining your variables very well. And now here they are asking number of workers in each section of the farm. So friends, don't just rush and you say let God be X. No. Come here and you respond to the task. So here we shall say, let the number of workers in cattle section, cattle and goat section be X and Y, respectively. Now, you come and connect. It's better to draw a table, but here I'll just explain. If X workers are working in a cattle section, come and ask yourself, how many heads of cattle does each worker take care of? 50. So here we shall come and we ask ourselves, if there are two workers, it means that now those two workers will take care of 100 heads of cattle, because you will get unit times quantity. So for this case, we shall come and we say 50x as the number of cattle taken care of by X workers. Then plus also each worker here, how many goats taken care of by one person, 30. And how many workers? We will say that is y. So we shall say 30y is equal to, now these are goats and then goats. These are animals now. So we get a total of 310 animals. So this is the equation 1 for animals. Then also see the second condition they are saying. Each worker working in a cattle section is paid 150. And then each worker working in a goat section is given 100,000. So you'll come here and you say, how much do workers in cattle section get in total? How much does each get? 150,000. Then times the number of workers, that is x, plus how much does each worker in goat section earn? That is 100,000 times the number of workers shall have 100,000 y, then is equal to 950,000 as the total amount of money. So these are the simultaneous equations, and this is equation 2 for what? For salary. Now, after reaching that, you can see that these are simultaneous equations. So it's better you reduce them so that they can become simpler to be solved. So here you'll come and say 50x then plus 30y is equal to 310. But if you go on dividing 50x then plus 30y is equal to 310, you go on dividing by 10 now. DCF by 10 throughout. So we'll get 5x plus 3y is equal to 331. Then similarly here, still come here and you say that still you can come and you do the same here. Say 150x then plus 100,000 y is equal to 950,000. So here, if you go on reducing, how many zeros are you seeing? 4. Go on dividing by 10 zeros, 4 zeros, even here 4 zeros, and then here you can come and also divide 4 zeros. But still, a number is divisible by 5 if at all. Maybe let me first do this. So here we get 5x, then plus 5x, 15x plus 10y is equal to 95. So divide by 5, you divide by 5, you divide by 5, so that you can deal with a simpler number. So here we shall have 3x, then plus 3y, then no, plus 2y is equal to 19. So these are the simplified equations. And also this one. So those are the ones that I want to deal with, such that I can easily get the value of x and y. So allow me, maybe I can write them here, such that I have here first equation, 5x plus 3y is equal to 31. Then here I have 3x plus 2y is equal to 19. So allow me take off this one so that I can create a space. But that's what I wanted to show you. It's better you reduce them. Allow me take off this. 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 So now, after I'll come here and I say, now my simplified equations are, I have 5x, then plus 3y is equal to 31. And then I have 3x plus 2y is equal to 19. Now we have different methods of solving simultaneous equations. We have matrix method, we have graphical method, we have substitution method, but the best method here, the simpler one, is elimination. And elimination is all about removing. So you just come here and ask yourself, if I'm intending to eliminate y, I'll put here, it means that on subtraction I should be having same values of y. So here we shall say, you come here and you put here a 2, the coefficient of y in the second equation, multiplied throughout the first equation. And also the coefficient of y in the first equation, you multiply it there in the second equation throughout. So let us multiply and we see 2 times 5x I get 10x, then plus 2 times 3y I get 6y is equal to 3 times 31, I get the answer as 62. 2 times 31, I get 62. And then 3, please, these two should multiply all parts of that equation. Then you come here and say 3 times 3x, I get 9x, then plus this 6 times 3 times 2y, I get 6y is equal to. Now come here and you ask 3 times 19, I get the answer as 57. So you come and subtract those equations. So here we shall have the answer as x, because 10x minus 9x, I get 1x, but I'm going to put there x. Then plus 60y minus 6y, I get a 0. Then is equal to this one, 62 minus 57, I get the answer as 5. So x plus a number is that number. So if okay, let us maintain there 0. So we shall have our value of x as 5. Now, after getting the value of x as 5, please go ahead and ask yourself, I have here my equation. Here my equation is 5x, maybe let me use this one. After getting the value of one variable, use any of those two equations to get the value of the second variable. Now, you can use this cheaper one. Come here and you say 3x plus 2y is equal to 19. But I have my x as 5. X is equal to 5. So come and say 3 times 5 plus 2y is equal to 19. And 3 times 5, the answer is 15. So we shall come here and we say 15 plus 2y is equal to 19. So we shall remain with the 2y is equal to 19 minus 15. We shall have 2y as 4. I divide by 2, I divide by 2, so I get my value of y as 2. But don't just get your values of those variables and end at that. No. Go ahead and you give a conclusion. Now, what did x represent? That's why I've kept this statement there. X has represented number of workers in the cattle section, and then Y has represented the number of workers in the goats section. So come and give a conclusion. Say it means that there are 5 workers in the cattle section and 2 workers in the goat section. So that's how we would respond to the first part of item 2. Senior theories master these simultaneous equations. They are very important in our day-to-day life. So allow me take off this, and then we run to the second part of that item. Now, this item here, number 2, part B. Here you would attempt this in 2 ways. Number 1, you would attempt this using direct proportion. As you see, a direct proportion. Under direct proportion, when one quantity increases, another quantity also increases. And when one quantity decreases also, another quantity decreases. So this was the direct proportion, because you see when he sold 100 liters, he got 150. When he sold 80 now, after the quantity of milk reducing, also the amount from sales also reduced. And then when it rose to 120, also the amount rose. So this was all about direct proportion. So here would come the first thing is 1. You come and say let number of liters, here we can say you can come here and say, first of all, remember you have to form an equation, and an equation must have variables. So let's say let the quantity of milk sold be x, and amount got be y. So it means that y is directly proportional to x. The amount of money got from milk is directly proportional to the quantity of milk sold. When the quantity of milk sold increases, also the amount of money got from milk after selling it also will increase. So we shall come and we say that y is directly proportional to x. To remove this proportional sign, I'll come and I say y is equal to x, of which k is the proportionality constant. Now come and pick 2 results here. You can choose this one to be x and then this one to be y. Any of these 3, the one you use, you will get the same answer. So when x is 100, y is 150,000. So come and you say 150,000 is equal to k times 100. Then here we get 150,000 is equal to 100k. You divide by 100, also this side divide by 100. So you get k, the value of k as 1,500. So the equation is equal to 1,500x. So this is the equation. Now when you see this equation here, this 1,500 is the cost, or is the price, the constant wholesale price for each liter of milk. So we shall now take this one. So this is our equation. And then here state. So we'll say the constant wholesale price is the constant wholesale price is equal to 1,500 shillings. And then another part even was saying that calculate the amount of money she is likely to receive for the sale of milk next month. So after here, don't rush. Now you ask, here they are saying the farm is likely to produce 135 liters next month. Please always learn how to interpret these questions. So come and say y is equal to 1,500 x. Then ask yourself, when x is equal to 135, remember x represents number of quantity of milk. Then here y, I don't know its value. So come and substitute. Y is equal to 1,500 times 135. Then here we have our value of y. Our value of y as 2. Then here 500. But don't end at that. Come and give a conclusion. They just put here that she is likely to receive this amount, 202,500. Conclusion is very important. So that's how would respond to item 2. But similarly, even if one did not use proportions, still you would use it using the equation of a straight line. Maybe allow me to take off this just very fast. So I would use the equation of a straight line. It's better to come here and ask yourself, do you see this first month? Let me put here A, and then the second month, let me put here B. Remember, we have already laid. So if I have my point A, B, the quantity of milk, and also the amount of money collected in that first month. Here we have 100 and 150,000. Then second month, I'll have 80, and at the same time I have 120,000. But now remember, this is x and then this is y. This one is x and then this one is y. Now let me call this one x1, y1, and also I make this one x2, maybe either making this one x2 because it is bigger to avoid negatives, then y2, then x1, and then here y1. But remember, the equation of a straight line is in this form: y is equal to mx plus c, of which m represents the gradient and then y represents the y-intercept, c represents the y-intercept. So it's better to find the gradient here, and you come and say m is equal to change in y coordinates divided by change in x coordinates. It's y2 minus y1 divided by x2 minus x1. And then here we shall have m is equal to y2, which is 150,000, minus y1, which is 120,000, divided by x2 minus x1. x2 is 100 minus x1, which is 80. So here we have our m is equal to here 150,000 minus 120,000, you get 30,000. Then 100 minus 80, I get 20. Now here, when you come and divide, get the value of m as 1,500. So come back and check. Y is equal to mx plus c. But I have my m as that. So come and fill it there. Y is equal to 1,500x plus c. But still, you use any of these 2 points now to find the y-intercept or the value of c. The value of c. Now, you come here and substitute. Taking point A, which is 100 and then 150,000. This one will be x and then the other one will be y. Now kindly see here what I'm going to do to find the value of c. Now, what is our y? It is 150,000 is equal to, what is our x? It is 100. So come and say y is equal to 1,500, then x, but x is 100, then here plus c. So we should get 150,000 is equal to 150,000, then plus c. So to find the value of c, you'll get 150,000 minus 150,000. So you get the value of c as 0. So that's why here you would use come now and say y is equal to mx plus c. Do I have the gradient? Yes, the gradient is 1,500. Do I have the y-intercept? Yes, and the y-intercept is 0. So you come now and write your equation very well. So here I would get our equation as y is equal to 1,500 x plus c, but our c is equal to 0. Then reaching here, still you do it the other way. If you have x now as 135, then you can substitute and get the value of y. So this equation, you do it using ratios and proportions. At the same time, the equation of a straight line. So senior 3, term 1, you studied the equation of a straight line, finding the gradient, at the same time writing the equation of a straight line in the Cartesian coordinate form, or gradient intercept form, and that is y is equal to mx plus c. Subscribe, like, and share for more videos, and make sure that you tap on that notification button so that you can get any video that we may upload on our channel Math Connect. And also you can contact us on our WhatsApp number. Also send us our email. Thank you so much for watching. Meet in the next session.